I'm Luka. I've been doing CI/CD and SRE for almost 10 years. I did Jenkins, GitLab CI, GitHub Actions, Flux, all different things. They all have problems, and that's what we're going to talk about today and how it's solved with Kuberik that I work on these days. So main topics of today is why pipelines are the wrong shape for CD, what's the Kuberik's mental model, the resources for Kuberik with examples, how do we operate Kuberik in production, and then we'll get to some demoing questions. So this is how the old pipeline looks like in almost every tool that you used before. You do build, test, deploy, maybe you do some health checks at the end, and that's done. And then you hope that it all goes well. This is a happy path. The problem with this, at least these three problems, is that you have to build a whole pipeline by yourself, right? If you ever work with Jenkins or GitHub Actions, whatever else, you write the steps yourself, and you have to build it for each application that you deploy. Second problem is that it's indeed just linear. So if you're very conscious about SRE stuff and you're thinking about what happens if production breaks, what happens if we need to have a hotfix, what happens if we need to roll back, there's nothing in this linear model that models for that. And then also, you usually don't get environments out of the box. You usually have to say, now I'm dev, now I have to promote to staging, now I have to promote to prod. All manually, you have to check a bunch of things to make sure that the application is healthy and that you can go on. The thing is, we know how a good pipeline looks like. This is from AWS and how they deploy their stuff. You can read about it on AWS Builders library. So usually we have what they call Gamma. It's a canary check and canary deployment. And then you have health checks. You monitor the metrics. You can do automatic rollback. You wait for some time called bake time to make sure that it's all good. And then you can also run some integration tests, smoke tests, and whatever. And then you promote to another environment. So what we're trying to build with Kuberik is, instead of pipeline scripts, we declare declarative resources. Instead of happy path, we model the exceptions as well, what happens in production. And instead of scripting a bunch of stuff, you get components that you can just plug in. So how it compares to what we already have on Kubernetes is, maybe you already work with Argo CD and Flux, and maybe you tried rollouts, Argo Rollouts or Flagger for canary deployments. These only do some part of CD pipeline. What you're missing is, when does your version go live? You usually have to declare this with some sort of CI, or how do you verify? Rollouts and Flagger, Argo Rollouts and Flagger have verify step, but because they don't know why your version was changed, they can roll back even a hotfix during a production incident. You don't want that. And then there's no solution for promote at all. You would still have to write your custom script or CD. And that's what Kuberik solves. All these components are modeled in Kuberik in a nice declarative way. We'll get into specific examples later. The core, one of the core components of Kuberik is how it detects, how does it start this pipeline. The traditional pipelines start the moment you commit to the Git repository. But here instead we say, OK, you release your thing whenever you want to release it, and push it into OCI registry. And this can be either a Docker image or your Kubernetes manifests. And then Kuberik picks those up and runs them across all the environments. So promotion, Kuberik just updates Flux CD, which some of you might already have. Says deploy this version instead of just deploy from latest. And the cluster doesn't need Git. Like, one thing that always bothered me about Flux and similar tools is that you have to clone your entire repository, which seems quite awkward. And this is Kuberik in a nutshell, like the very large picture. So what I was talking about on the previous slide is Kuberik detects a release and then goes through this loop. First off, it has to check that some things are satisfied, that there's no rollout already running, that everything is healthy. If we're not in an incident, we don't want to roll out a new version when there's an incident. We don't want to roll out when it's paused because we perhaps rolled back also. Another thing that it checks before it does the update, you can specify manual approvals. So if you want to approve all your releases manually, you can do that. You can also say, don't roll out on weekends or don't roll out on Friday afternoon. And it can also, I'm going to show this later, we can also use this mechanism to actually sync environments. So we don't need a special modeling for environments. We can just use gates. Then we update. We have standard Flux. Then we have OpenCruise canary instead of Argo rollouts and Flagger. I'm going to talk about it later. And finally, it checks all the health checks. You can integrate with Prometheus, Datadog. You can run smoke tests. And it also verifies Kubernetes resources. You can also run additional actions, like if you need to override the version, you can pin it. You can force upgrades. You can roll back yourself. And all this is modeled into a loop. So practically, what you need is just these 4 resources. You need a resource, this is coming from Flux, that just detects that there's a new release. Kuberik has a new custom resource that says like how the upgrades are going to be managed. Basically just points to the version and specifies bake time. It can also specify a selector for health checks. Customization is still, like Flux customization is still the one that actually applies the manifest to production. And if you want to deploy just a new Docker image, you can specify that you do M substitution with Flux. And your deployment would then look something like this. You would have a version that would be substituted by Flux that was injected by Kuberik. And that's how you deploy new versions of your application. Moreover, if you want to make your pipeline more robust, you can introduce health checks. 2 most common ones would be what I call customization health check, which checks all the resources that are deployed by Flux. So it checks whether a deployment is in a healthy state and so on. And you have a Prometheus health check that checks if there's any active alerts. Then what I was mentioning before, we also model canaries with this. We use a specific canary controlled from OpenCruise that doesn't implement rollback functionality. And that's really important because if you're in an incident, you don't want your canary controller to roll something back because it doesn't know why you upgraded the version. So if you upgraded the hotfix, Flagger and Argo Rollouts could roll that back. OpenCruise doesn't. You just specify how you want your canary to look like, what percentages of replicas or traffic there needs to be, and it does that. And Kuberik also extends it so that it can run rollout tests independently. And if you want to go even further, now you have multiple environments. To connect the different environments, all you need to specify is this environment custom resource that specifies that it has to connect to Git, and you specify a relationship between environments. why we use Git here is because to sync different application across different environments, we still need some central hub. Because Kuberik runs on each cluster independently, we don't have that central hub. So we can use GitHub Deployments API, that's completely fine. So staging runs in a loop. It notifies that some version is healthy. It posts that to deployment API. Production environment watches that and says, OK, like for that version that's healthy in staging, I can deploy only those versions that are healthy in staging. And it fires up its own loop. Also to talk about production handling, right? With the pipelines, you don't get anything out of the box. Like, you don't get any modeling for how to do hotfixes, how to do rollbacks. You're just on your own. Kuberik implements this both in CRDs and in the dashboard that I'll show later. You can pin a version by specifying wanted version, or you can just force upgrade to a newer version if you want something to go faster. For example, hotfix that's not yet been verified in staging. And this is another example of like what happens in a production environment, right? Each environment or each Kuberik instance is just running its own loop. If you add a traditional pipeline, like dev, if you go from dev staging to prod, dev would tell staging that it needs to deploy. And staging cannot say anything about it. Because Kuberik models its own environment. It says production can only deploy when production decides to. Staging can only say, you know, this version is ready or not. But production, if, for example, incident happens in production and your health checks are not fine, you don't want to promote to a new version. Even if that version is fine, you don't want to introduce additional mess into your environment. So what you get out of the box are real resources, not pipeline scripts. Each environment is autonomous. It cannot be broken by other environments. Operational patterns are built in, so that's really important. And I really like this one, but it stays out of your Git repo. Like, you just need to deploy OCI images, and you don't need to clone your Git repositories in production anymore. I'll do a demo now. We're a bit ahead of schedule. And then questions later. All right. So what I have here is a demo app that's deployed across 2 environments. I have a script on the side that's generating some traffic so that we can see what's going on. First thing that we're going to do is we're going to push a new version. When we push a new version, both staging and prod will detect that the new version came in. But prod won't deploy the new version because it depends on staging. Right? Only when staging is fully deployed, only then prod can deploy too. So staging is deploying now, as you can see. And if you go to all environments, prod says here it has a new version, but it's blocked. Now, one more thing that I'm going to introduce is I'm going to simulate an incident on prod, just so that you can see that even when staging deploys fully, but we have an incident, prod will still not update. So now it says deployment is paused because, as you can see here, there's an active incident. And staging is probably still deploying. It's going to take some time. There's a bake period, so staging also has some health checks. you can also run rollout tests. During this time, we'll ensure that maybe the incident doesn't happen immediately after you deploy. It can take some time. That's what bake time is for. I can also maybe speed it up. Yeah, that's fine. In the meantime, for the next step, we're also going to push an image that is actually broken. This image is going to return errors on the requests, and we're going to be able to see that here. By the way, you can also see that currently staging replies with the new version, and prod is still on the old one. All right, so we're gonna, because we're syncing to GitHub deployment API, it can take some time. Like it syncs about maybe every minute. So it can take some time to register that staging indeed got deployed fully. We're currently deploying this to a single cluster, but you can also assume that it's deployed to multiple clusters, and then it's just syncing via GitHub deployment API. Yeah. All right. So now it says it's ready, but it's still not deploying because deployment is paused. So we're going to clear the incident, and then it's going to continue on its own. So now for the second step is we're going to push a broken image, and we're going to see that the requests start to error out. So it's being it's built, it's detected, Kuberik is rolling it out. It's first gonna roll out one pod at a time. So we're gonna see, you're already seeing it's flipping between internal server error and previous version. Once it finishes rolling out, it's gonna switch to bake time. And then what we're going to see quite soon is that because we have also recording errors here, the high error rate alert will fire. It's going to go to firing first, yeah, and now it's going to, it's pending, and now it's going to go to firing, and the bake will fail. Three, two, there we go. And then the rollout stops, right? And if you go to another environment, of course, prod still says here blocked. It doesn't still have information about the, and now it has information that the previous environment failed. So it would not ever deploy this version. Then I modeled this demo to do manual rollback, but the idea is that you can also do automated rollback once Kuberik clearly knows it's failed. And yeah, then we just pin the version to the previous one that we know is healthy, and this is going to roll out really quickly, and that's the end of our demo. And now, if you want to, if you have any questions, I'm all open for it. We have 10 minutes, 5 minutes, 7.
Awesome. Woo.
Thank you.